Oh, sure. Donating money to make the situation more stable for these tigers is the least I can do.
Thank you, teacher.
Actually, me donating some money to make the situation more stable for these tigers is similar to some elements donating their extra electrons.
Okay, what do you mean by extra electrons?
Do you remember about the stable duet and octet configurations of the noble gas?
Yes, but a quick refresher would be nice.
Okay, so helium is stable because of its duet electron configuration.
Duet meaning 2. So helium has 2 electrons in its first and only electron shell.
Yes, all the other noble gases are stable because of their octet configurations. Octet means group of 8, and you'd notice that they're in group 8 of the periodic table.
That means that they have 8 electrons in their outer shell.
Except for helium, yes. Atoms with 8 electrons in their outermost electron shell are very stable, and we call this electron configuration the stable noble gas configuration.
Stable noble gas configuration. Got it?
In nature, we find these noble gas atoms as single, uncombined atoms.
While all the other elements in the periodic table does not have this stable octet configuration. Thus, they must react with each other or with other elements to achieve it. I recall now from our previous lessons.
Very good.
So, only after achieving this octet electron configuration that these elements would be stable?
That's right.
So what does it have to do with donating extra electrons?
Before we discuss the extra electrons, let's talk about valence electrons.
Valence electrons?
Valence electrons are electrons on the outermost electron shell. And the outermost electron shell is called the valence electron shell.
Oh, so that's what it means. Okay, got it. Okay, teacher, let me do a quick recap now. The only stable electron configuration belongs to the noble gases.
Yes.
Helium, as the first noble gas, has only 2 electrons. So its stable electron configuration is called stable duet configuration.
Correct.
All other noble gases have 8 valence electrons. So this stable configuration is called stable octet configuration.
Correct again.
So, since all the other elements in the periodic table do not have 8 valence electrons, that means they are unstable.
Yes, and because they are unstable, they must react to achieve that stable noble gas configuration.
Got it. Teacher, I think some examples would be great.
Sure. Take a look at groups 1, 2, and 3. They all achieve the stable noble gas configuration by donating 1, 2, and 3 valence electrons respectively. And because the electron has the relative charge of -1, when the atoms donate electrons, they become positive ions.
Okay, let me see if I understand what you are trying to say. Let's look at group 1. All group 1 elements have 1 valence electron, using sodium as a representative of group 1. If it donates 1 electron, it will achieve the stable noble gas configuration of neon. Thus, it becomes a sodium ion with a +1 charge.
Well done!
Okay, that is for group 1. Let me try for group 2.
Sure, give it your best shot.
All group 2 elements have 2 valence electrons. Using calcium as a representative of group 2, if it donates 2 electrons, that it will achieve the stable noble gas configuration of argon. Thus, it becomes a calcium ion with a +2 charge.
Very good. And it's the same for group 3 elements. They donate 3 electrons to achieve a stable octet electron configuration. For example, aluminium donates 3 electrons to achieve the stable neon gas configuration. Thus, it becomes an aluminium ion with a +3 charge.
But teacher, those are elements in group 1, 2, and 3, and thus they are all metals. How about the nonmetals on the upper right section?
You mean, how do they achieve the stable octet configurations?
Yes. Do they donate electrons too?
Well, while metals donate electrons, nonmetals receive them. Let's take a look at groups 5, 6, and 7. Instead of donating 5, 6, and 7 electrons, it is much easier for them to just receive 3, 2, and 1 electrons respectively to achieve the stable octet configuration.
Ah, I see.
And because electrons have negative charge, any atoms that receive electrons will become negative ions.
Can you give some examples, please?
Sure. Let's look at group 7 elements. All group 7 elements have 7 valence electrons and will receive 1 electron to attain the stable octet configuration of a noble gas. Using bromine as a representative of group 7, it will receive 1 electron in order to achieve the stable octet configuration of krypton. Thus, it becomes a bromide ion with a -1 charge.